Let's do one more example in section 9.2 here of converting from exponents to radicals, and that would be problem number 46. So problem 46 is 4/9 raised to the 3/2. So a way to do this would be to imagine a little boot here. It kicks this number over here. The 2 comes over. The 3 drops down. I get the square root of 4/9 cubed. Now if you wanted to, you could do this in a lot of ways, including your calculator. But let's see if we can do it without our calculator. And the way I would suggest is start by doing the square root first. Let's do the square root of 4/9. So do the square root of the numerator. Square root of the numerator is 2. The square root of the denominator is 3. But I haven't taken care of the cube there. So these are both still cubed, but that's not too bad. What's 2 cubed? And 3 cubed? 27. Now if you're careful, you can do those on your calculator as well. But you need to use parentheses. So we'll do parentheses 4 divided by 9. Oops, be a 9. 4 divided by 9 raised to the, and again, depends on your calculator. You might need to use parentheses in the exponent as well. I can get away with 3 divided by 2. I get some crazy looking decimal, but then hit the math key right here, and then press enter twice, and it should turn your decimal into a fraction. So nice. On the exam, I'll probably give you one where I say, all right, here's this expression, give me an equivalent fraction. And if you do it on your calculator or if you do it by hand, it makes no difference to me. I want you to be able to come up with that kind of an expression. Now, we've done a lot of practice with those. Let's see. Let's do one last follow-up, problem number 50. 27 a to the third b to the third raised to the 2/3 power. So this one is a little reminder of the fact that when you have an exponent on the outside, it's going to multiply each of the exponents on the inside. So the one thing we got to be careful of is remembering that that's 27 to the first power. So this exponent on the outside multiplies each of those. So I get 27 to the 27 to the 2/3 power. What's going to happen when I multiply 2/3 times 3? I'll get a to the second. So a to the second, b to the second. The only thing I have to worry about in terms of fractional exponents is 27 to the 2/3 power. And we've worked on this one before. That's just going to be the cube root of 27 squared. These are not under the radical. Cube root of 27 is 3, and 3 squared is 9. So 9a squared b squared. But let's start going in the other direction. Let's start converting expressions with radicals to expressions with exponents. And we'll start with problem number 58. So 58 is the 7th root of 7p squared q. What I would suggest is that you take this expression under the radical and we'll put it in parentheses 7p squared q, all raised to the first power. The reason for that is because it sets us up for what you might remember as an old football play. It's called the reverse boot. So the 1's going to come up and the 7's going to come over. I'll get 7 p squared q raised to the 1/7th power. And that's it. You've converted from radicals to exponents. Now, a lot of times I get an answer like this: 7p squared q raised to the 1/7. Is that the same thing? No, why not? Good. It's only the q that's raised to the 1/7. Equivalently, this would be 7p squared and then the 7th root of q to the first power, because that 1/7 only applies to the q. If I wanted to apply to everything, I need it in parentheses. It's kind of like your question earlier. Let's try another one. Problem number 60. I like reviewing number 60 because there's a few little tidbits in here that are worth discussing. Square root of x squared plus y squared. The temptation for everybody is just write, oh, well, that's x plus y. Not true. As I said earlier, you can't separate square roots by writing it as a square root of one plus a square root of another. You can't separate this unless this is a multiplication or a division. Doesn't work for addition or subtraction. So what can we do? Well, let me rewrite it and add a couple things. First of all, even though we typically don't put it here, what number is understood to be out in front of the radical? A 2. So let's put a 2 out there. And like problem number 58, let me put some parentheses here and put an exponent. What exponent can I put here? So the first power. And now let's rewrite it. So, Norman, what would that look like if I wrote this with exponents? Good, to the 1/2 power. Something to the 1/2 power is just like a square root. Can I simplify it from here? No, you can't. It looks tempting, doesn't it? I mean, that 2 and that 1/2, they cancel each other just perfectly, right? But I'm telling you, if I put one on here, please don't go any further. That's it. That's as far as you can go. So I know it's tempting. You know, if I had more time, I'd show you that if you squared x plus y, you would not get that. It just doesn't work that way. Let's try something with negative exponents. Number 66. 49 to the negative 1/2. Well, we mentioned negative exponents way back at the start of this section. What can I do with something to a negative exponent? 1 over that. 1 over 49 to the 1/2. 49 to the 1/2 is like the square root of something, so this is really 1 over 7. If you did 49 to the negative 0.5 power in your calculator, you'd get the decimal value for 1/7. Let's try problem number 94. Cube root of 7 to the 3rd power. Now this one we're going to be doing a couple things. First, we're going to convert it to exponents, and then we're going to convert it back to radicals after we simplify it. So for the first part, converting it to exponents. Kennedy, what would that give me if I rewrote this using exponents? 7 to what power? Good. 3 over 6. And 3 over 6 reduces to 1/2. And now let's write it again using radicals, because we've simplified this a little bit. What is it using radicals? Square root of 7. And you don't need to write the square here, or the 2 here. You don't need to write the 1 here. You can just write the square root of 7. But nice. We got some nice simplification out of that one. Why don't you try problem number 98? I'm going to write that down for us. It's the 8th root of 9 squared. Q? Oh, it's a Q? Better yet. Good, because I was looking at that going, you know what? It's a, you know, if that's a 9, that's going to be a bigger mess. That's a Q. Thank you. Q squared. Boy, that solves a lot of problems for me. Thank you. So with exponents, that's q to the 2/8, better yet, q to the 1/4. And overall, what do we get? Jar yourself a little boot. Something slides over. Go to the fourth root of q to the first power. Or better yet, just the fourth root of q. Cool. One last one. This would be kind of a perfect challenge for you on an exam. And that is problem number 114. 16 to the negative 5/4 power. See if you can't write that as a fraction. Just simplify it and write it as a fraction. I don't care if you do it on your calculator or if you do it by hand. But try and write that as a fraction. Should work out really nice. You copied it down, right? Okay. All right, so let's see about doing it by hand first. So by hand, I'd rewrite that as 1 over 16 to the 5/4. I don't think I necessarily need the parentheses anymore. The parentheses are there just to separate the negative and the 16. So rewriting that as a radical, that'd be the fourth root of 16 to the 5th power, which was 1. Do the root part first. Fourth root of 16 is 2. 2 to the 5th power is 32. So 1 over 32 should be your final answer. If you do it on your calculator, you should again be able to get that same kind of answer. So 16 raised to the negative 5 divided by 4 gives you that. I'm going to ask for not a decimal, but a fraction. So please turn that into 1/32. Is everyone able to get that one way or another? We're all good? Any misgivings? All right. Let me give you some homework. And we'll move on to section 9.3. So for homework, try 17 through 51, 57 through 85, 93 through 97, and 109 through 119. That's section 9.2. It may sound like a lot, but I'll give you 5 days to do it. Actually, I'll give you a week, right? Isn't this Monday? Is it Memorial? No, 2 weeks. It's 2 weeks will be more. All right, so you got 5 days to do it.